Hello. I'd like to thank Dr. Talby and the rest of the John Snow Labs for inviting me to speak at this incredible summit, sharing all of our experiences with advancing natural language processing to improve health outcomes and end user experiences. Today, I'm excited to share with you details on how the Department of Veteran Affairs has begun to implement enterprise-wide governance and technology systems to help support our veterans while implementing artificial intelligence solutions. So many of you may wonder why there is great value in the Department of Veteran Affairs introducing and really investing highly in artificial intelligence. There's many major factors that influence our need to use. One of them is that we have over 10 billion medical images available to us to implement wide-scale, very precise computer vision products. In addition to that, we have over 9 million active patients. We're the largest integrated healthcare system in the United States. We have over 1,200 medical facilities. We have 120,000 clinicians and approaching 1 million genomic donations, which gives us the largest genomic database tied to medical records in the world. So what drives our ability to do artificial intelligence? One of the biggest driving factors is there was Executive Orders 13859 and 13960. These executive orders were released to help guide and drive the federal government's ability to be leaders in artificial intelligence throughout the world. What it really promoted was not only the use of trustworthiness with our AI, but really expanded our capabilities of partnering with academia and with industry partners that could really help us improve and advance our artificial intelligence in ways that previously were very difficult to achieve. We've also spent a lot of time and resources on developing national AI research and development strategies, as well as AI strategies for the Department of Veteran Affairs, as well as continuing to deliver joint strategies between the Department of Defense, Department of Veteran Affairs, and now we continue to expand that into many other agencies. And then finally, the 2021 National Defense Authorization Act gave us the ability to really coordinate AI research and policies across the federal government. As many of you might know, healthcare data, specifically veterans data, is incredibly sensitive. And one of the core barriers that we've had to overcome and continue to work with is how do we either synthesize data that's very relevant to our population, or how do we de-identify or create secure sharing environments in order to improve. So our vision and our mission of the National Artificial Intelligence Institute is really to become a premier global institute for research, implementation of artificial intelligence, policy development, and collaboration. And obviously the core of all of these is to help enhance the outcomes for our veterans. I would also say that we are also really beginning to focus a lot on how do we improve our workforce's quality of life while at work, how do we improve workflows, and really how do we help reduce the provider and nursing burdens that we've all in healthcare been experiencing and trying to rectify. So as leadership, we kind of thought through and really worked through how do we enable our leadership and others to create AI use cases, and how do we do that with building our AI R&D capacity. And we focused on 5 kind of primary areas. We have deep learning, trustworthy AI and privacy preserving AI, as along with explainability and multi-scale AI analyses. Obviously, um, as the federal government, um, trustworthiness and protecting the privacy and being able to present explainable models to our clinicians who make very critical healthcare decisions are very core values in all of our projects. Deep learning, I think we all have a pretty good understanding of this conference, but we just want to make sure that whenever we are utilizing deep learning models, it's when they're really necessary, and that we are ensuring that the features and other data that are helping to drive it are not only protected, but also are cleansed as well as formatted and presented to those models in a way that helps to not only optimize our ability to execute them to reduce cost of computing resources. As you can tell, we're a very large agency and things can kind of run away pretty quickly on us. And then finally, to just make sure we have really good precision on the outputs. Trustworthy AI is really, really core, and that is what we have focused a lot of time and resources on the first couple of years. We can't be successful in this endeavor if we don't have the proper ethical framework and we aren't able to implement models that are reliable, have proper AI ops surrounding them, and have really good ethical regulatory constraints around them that make sure that our technical models and our technical environments that we use um, help to properly support achieving those goals. Privacy preserving, we're in the healthcare industry. I think we all are very cognizant of the need to do that. In the VA, we are particularly cognizant as we carry very valuable information about um, veterans. That information we need to make sure not only is just safe, but also isn't exposed in a way that could create dangerous situations for those who did serve um, during times of war and in hostile situations. We want to make sure that our AI analysis obtain results without exposing underlying data. And to do so, we got to make sure that we have source privacy, input privacy, model privacy, output privacy. And then what we're really working through is, when we're working with academic and industry partners, where's the destination of that information going? What can we allow to be out? Another challenge we have is most of our opportunities to collaborate as well as implement new strategies and is through SaaS or PaaS models that are out in the cloud. These require a very rigorous FedRAMP approval process to enable our data to be housed within their environments and do AI. And so we're working through very um, various improvements in our ability to adapt and integrate traditional external SaaS applications into our VA Enterprise Cloud environments, into our Summit Data Platform, which is kind of our new Delta Lake driven, graph driven, multi tool, multi cloud tenant for data analytics. And we're having a lot of good success with um, programs like VA Platform One, which can leverage Red Hat, OpenShift, and other sources to bring them in. Obviously, we have to make sure that everything that's in the black box is understandable, that the output is understandable, and that there's trust in the data that's being used by the clinicians to treat the patients. And then obviously, as we progress, there's a lot of excitement around multi-scale AI analyses, and I think this is where the VA is just really positioned well to make some really significant advancements in patient outcomes. What are our strategies? How do we execute these priorities? We want to build a robust community and network around artificial intelligence. One of the things that we've done is to develop 5 field sites. My site in Kansas City, the Kansas City VA, has a team that we call Mindset. It's an informatics and emerging technologies group. And the National Artificial Intelligence Institute, or the NII as we call it, um, has incorporated our field site and 4 others kind of into a network to help expedite the advancements. There's been a great prioritization investment in AI. We need to reduce the barriers to translating advances into real world. This is a very complex process. Not only do we need to deal with trustworthiness issues, explainability issues, we also have to deal with very robust security issues and computing capabilities on how we do that. And we want to make sure that we adopt models that are tailored and trained to the VA's mission. Um, we want to be very careful about grabbing models that weren't really trained in our population and trying to implement them and expect the same type of outcomes. Trustworthy principles, I think we all are becoming more and more aware of this. We just want to make sure they're lawful. All of our AI projects are respect our nation's values. We want to make sure they're purposeful and performance driven. Got to make sure they're accurate and reliable, safe and secure, explainable. We want to make sure that we're being very responsible about how we do it. Ensure that we have very good AI ops and other mechanisms in place for being able to trace the lineage of the data and the outputs. We want to make sure we're regularly monitoring these for bias and for deviations from the expected outcomes. Got to make sure there's a lot of transparency. And we need to hold people accountable with governance structures that really help to drive the principles that are necessary to be successful. Um, Here is just a little bit of elaboration on doing some affiliations with medical centers. I'm really working strongly with academic partnerships, working with external partners in industry, um, helping to develop very significant enterprise-wide data governance and technical governance councils that help to guide and provide a very good infrastructure. We've implemented site-specific AI councils as well as embedded very specific templates and regulations um, into the Investigational Review Board or IRB practices. All right, so this is kind of my way to help people see a little bit of how JSL has really helped to empower us, and we're only on the very, very beginnings of it. And for those of you who are, Six Sigma qualified, lean manufacturing, one of the big things, and in healthcare, maybe more so in the VA than outside, is when we're going through a project, the nurses and the pharmacists and all the other staff in the facility really love to identify those capalities or those markings, the stars we put on our process flow maps to indicate that there's a barrier. As we all expect, um, particularly in healthcare, when we're working on very complex data integrations, we're working on data flows, process flows, even architectural integrations between different data sources, different platforms. Um, there is a ton of um, formatting, interoperability, data standards, terminologies, And discovery, data mining throughout these processes has become something that, because of the way technology has grown, we have really advanced capabilities that we weren't available a couple years ago. Um, and as we'll show later, the introduction of very robust large language models has only expedited our need to be able um, to introduce different instances of JSL tooling or other tooling to help with that medical entity recognition and to help us really clean the data in process. We're trying to go from a traditional process of where we have a data warehouse and we kind of rely upon individual queries, extractions, so forth, but really moving into that streaming pipeline type of opportunities where we're using um, very large single source delta lakes, mesh environments, um, graphing data architectures, so that we aren't having all of these disparate data sources all over the place. And John Snow Labs is something we found to be very helpful in helping the communication terminology standards to help unify those in our system. We're at a JSL conference, so we don't need to go over this particularly, but I think that it just really illustrates all the different toolings that are available to really help improve not only data, but as well as our ability to really enhance um, upstream um, data integration into our AI models, as well as helping to improve prompting and other necessary functions of LLMs. So, what did we do? We've done several things. This is the one that I think is currently most available to share. Obviously, we have lots of security risks and data with our others right now, but we're getting to a point where soon we'll be able to share. But this was just an example of partnering with Databricks and John Snow Labs and really looking at in healthcare which of these models that are out there. Um, this was about a month or 2 months ago. Would best fit with our population. One is that the libraries had to be able to be installed inside of our platforms. We couldn't use APIs outside because we can't share data outside. Um, so we took them and working with Databricks and a wonderful data scientist named Ching Soon and Matthew Bierce, we were able to execute several different evaluations using some of the SOTA models that are out there. How do we do that? We did that by integrating in our Summit Data platform, leveraging Databricks on Azure. We use our Delta Lake and CDW NextGen, which is the newish available data source that we have for evaluating data. A really good example of that by using Databricks and these new Delta Lake platforms, the computing infrastructure that Joseph DeOria and our data analytics team has put together has moved a query that once was about 7 hours on our traditional SQL servers. We have that down to 32 seconds now. So it gives you a really good idea of how we can really enhance our ability to use large language models. I'm going to go through this pretty quickly, but really it's just I want to kind of share with you the sequencing that we used for this particular one. Obviously, first, wanted to illustrate how easy it is to load John Snow Labs and Spark NLP tools into Databricks. We bring these libraries in and help support BioGDP, radiology models. We create summarizers, which you'll see is very important, as well as support many other pipelines. So you can see here at the top, we inserted a question in the prompt. The question was, what patients had an LDCT? So it semantically determined that was a low-dose CAT scan. So what patients had an LDCT after July 1st, 2023, and have emphysema? And so this is an attempt that we're using to really leverage semantics of large language to do data mining. And as you can see down here, not only was it able to identify the radiology reports, it also was able to pull back the report text. And then we used the summarization tool, which has been really incredibly helpful from John Snow Labs to actually create a summary that then we can introduce other large language models on top of to help with our accuracy and precision, we believe. Here you can just see the final pipeline merges all the different data sets and enables us to have a very discrete data output to leverage for all of our other downstream needs. What were our findings? Findings were that we definitely felt the chain of thought prompt engineering layered with JSL medical entity recognition and other tools significantly helped improve our accuracy, reduce hallucinations, and optimize our computing. We measured accuracy, relevance, and quality. You can see how we did that there. At the time, a month and a half, 2 months ago, of models that we could load into Databricks, Llama 2 performance was closest to ChatGPT among the models. And then finally, we used summarized progress notes. We took progress notes, radiology notes, and then we use JSL summarization tools to help optimize and help provide more precision. And then we also have done a couple things with medical center policies. And then finally, all the experiments were conducted in our secure VA cloud environment using Azure Databricks and with LLM artifacts stored in Azure, as well as John Snow Labs libraries that were internally loaded in our library. Finally, real quickly, future plans, lots of different discovery with LLM. We have a lot to learn with the John Snow Lab tooling sets. Very excited about adding a lot of enhancements to data mining, as well as the outputs that we're able to achieve. We want to inject JSL tools into our different pipelines, reduce the amount of disparate data sources that we're using. We want to implement and collaborate with JSL and clinical decision support tools, as well as other LLM support in the ambient technologies. We have a really exciting tech sprint being announced for introducing very future-based ambient technologies into helping provider and patient visits and into helping improve the workflow streaming with that into progress notes. But we want to take it much further to where we're really helping to guide in real time using LLM and other tools that clinic visit and helping to provide information as well as make decision supports. Going to be doing a lot of research data cleansing and want to expand our data sets with the extraction capabilities into progress notes. That's been a big gap, as well as leverage JSL tools to inject reliable and consistent features into our AI models. And I think this is very, very important for the future. Finally, we are super excited about collaborating with John Snow Labs, continuing to improve the amount of opportunities we have to inject their tooling into our different data streams, and really hope that by doing so that we can make a significant difference on reducing provider burden and obviously improving our patient outcomes and satisfaction. I'd like to really thank everybody for allowing me to be here today. It's a very exciting time. We really look forward to continuing to extend our collaborations and hopefully with many of you out there. Thank you all very much. Here's some information on how you can actually contact the National Artificial Intelligence Institute, and we look forward to continuing to drive us into the future. Thank you.